This video is a video on how to use the CODAP website. So CODAP is a common online data analysis platform, which is a really powerful tool for doing some data analysis and some statistical analysis. So we'll walk through that process. So you can visit the website by clicking on CODAP or going to codap.concord.org, or you can just do a search for CODAP. It'll be the first one that comes up. Once you get to the page, you're going to go into the top right-hand corner and click on Try CODAP. Now, you'll be asked if you want to open a document or browse some examples. There are a few examples of data sets that are there to play with. I want to show you how to bring in a document. So we're going to create a new document. And this is the environment here. It doesn't make a whole lot of sense yet because we don't have any data to work with. So let's have a look at how we do that. So in the top left-hand corner is kind of like this menu type of, well, that looks like a menu. So what we're going to do is we're going to choose import. Now, when you import, you need to choose a file that is a CSV file. So whenever you're in a spreadsheet or any kind of data, you can often save those files as CSV values or CSV, documents. And this program, as well as any spreadsheet, will open those. So I have a version of this document called mammals on my hard drive that I'm just going to upload. So I'm going to click on the middle part of the screen here. It will bring up the documents that I have, and here's the mammals document. I'm just going to drag it over, and here is what we see. So we have the data in this cases table. This tells us about when the data was imported. I'm not really interested in that, so I'm just going to close that by clicking in the top right-hand corner. Now I noticed that the dialog window for my open and close was still open, so I just closed that as well. And we can just drag on the corner here and see what this data is all about. So you can see here that this has a list of 27 different mammals. So it gives you mammal names, it gives you what order they're from, their lifespan, their height, their mass, their sleep, their speed, their habitat, and their diet. And you can make this window any size you want. Just because you can't see certain values doesn't mean they're not going to be included. So we have this set of data. I want to show you how to make a graph to start with. Let's start there. So we're going to make a graph. So to do that, we click on the graph button, and it gives us a graph. Now let's say we want to be able to graph height. So I'm going to just come over to the table. I'm going to click on the height attribute and drag it and stick it. I'm going to put it on the x-axis. And now I have a graph showing all of the heights. So once I've done that, I could do a few things. I can change, I should mention here that I can change how this graph looks. So if I wanted to basically shift the graph left to right, I can grab the x-axis. I can also do this for the y-axis later, but I can grab the y-axis in the middle. Notice the hand is up and down. If I move to this side, to the edge, the hand turns sideways. And what that does is that sort of compresses the data. It stretches, compresses and stretches. So if you grab by the edge, you'll get a compression or a stretch. If you grab in the middle, you can just shift it along. So that's how you can kind of manipulate your data a little bit. Now, maybe you want a bar graph instead of this kind of dot plot. So you can click on the graph. Oh, no, sorry, we can't do that. Thought we could do that. One of the things that you can do with the graph, though, is you can group into bins. So if you had a lot of data and you wanted to organize it and make it grouped data, you certainly could do that. Oh, here it is. And now we can actually fuse the dots into bars. So if you didn't like looking at the dots and you'd rather look at bars, you could certainly do that and see that here. I'm going to undo the bins. You can see how the bins might be a little bit useful, especially when you're talking about continuous data like this. And yeah, all right, so here's our data. Now here's what else we're going to do. So these are all of the heights of the different animals. If I click on the measure tool, I can actually show some different things like a count. So in the top right hand corner now, it tells me there are 27 items. That's good, it matches my table of 27. I can click on the mean and it shows me the mean. So you can see this bar, this blue bar has appeared, and it says that the mean height is 1.68. I assume this is in meters. And we can go from here. So if you were analyzing this data and you wanted to keep track of things like the mean, what you could do is click on the text box here in the toolbar, and we'll get a text box. And you can see we have a whole bunch of options on the right here, but I'm just going to make a text box. This is going to be a summary. So I'm going to change the title just by double clicking up here. And I'm going to call this Summary of Heights. So I can just write anything here. So here's what I found about heights. And we just found the mean was 1.68, if I remember correctly. Yep, 1.68. And we'll put some units in there. I don't think it says what the units are, but I'm sure that's what they are. All right, let's go back to our graph. And if you want the graph bigger, we could just click in the corner here and drag this out a bit to make it a little bit bigger. And again, I'll slide this out of the way, maybe make it a little bit smaller. All right, so I'm going to click on this graph again and go to the measure tool. I can also show the median. So you can see here's the median, the red line. The median is 1.2, so I'm going to go back to my text box, my summary of heights, and say that the median, let's try that again, there we go, median is 1.2. All right, now the other thing you might be interested here is the mode. You'll notice that when we click on measure, there is no mode here. But what we can do for the mode is we can kind of look at the data and say, all right, none of these are the mode, obviously. There's only one of each of these. Now, here's an interesting feature is that I can highlight all of these data points. And you can notice that as soon as I highlight it on the graph, it shows it in the table. So if you're wondering what a certain thing is based on your graph, you could highlight and click on it, and then it will show you in the table. But what I'm going to do is I'm going to click on this eye here, and I'm going to hide the selected cases. The reason for that is I want to be able to zoom in here. And so if I click on this topmost button, this is the rescale button, it will kind of spread this out. And now I can see where my mode is. So I can see that there's a mode here at 1.5. There's also a mode here at 0.9, which happens to be the median. This is the median of the data. I should mention that once I took out those other points, now it's giving me the median here. So just be careful of that. So it looks to me like the mode of the entire data set, there are two of them, and we said one of them was 0.9 and the other one was 1.5. Add some meters in here. Right, so now you might wonder, how do we get the data back? Like all that data that we didn't choose to see. So again, if we click on the eyeball and we show all cases again, it will rescale and give us all of the information back again. All right, so far we have the mean, the median, and the mode. What else might be useful? Well, how about the standard deviation? On the ruler, and there it is, standard deviation. So you can see it even shows sort of a graph of that standard deviation. And if we move over here, it says, so here's, remember the standard deviation is on average of how far each data point is from the mean. So here's the mean at 1.68. And then the standard deviation is plus or minus 1.55. So the standard deviation is 1.55 meters. So obviously the data is quite spread out with the standard deviation that's that high, and that's a result of these points way out here. All right, what else do we need to know? Oops. So let's go back here, choose measure. The other thing that we can do here nice and easily is a box plot. So you can see that it shows the box plot right on the graph, and we can have it show us the outlier. So just a reminder that when you do a box plot, anything that's more than 1.5 times the length of the box, so here's the length of the box from here to here, anything that's more than 1.5 times that from the edge of the box is considered an outlier. So what CODAP will do is it will show you the outliers if you put a check mark in that box, and now we can see there's our box plot. Now it doesn't give us the interquartile range, but we can move our mouse over top of the edge of the box and get Q3. We can get Q1 on the other edge of the box, and we can figure out the interquartile range from there. So it might be helpful to kind of keep those in mind. So Q1, add a little bit taller. Q1 is 0.7. Q3 is 2. And we can figure out the interquartile range from there. Q3 minus, minus Q1, which would be 2 minus 0.7. Space it out a bit. Gives us 1.3 meters. All right, so we've been able to find the measures of central tendency, and we've looked at the measures of spread as well. Is there anything else that we need to do here? I think that's probably it. So that's how we can use CODAP to find some one variable, do some one variable analysis. Now let's look at, the other thing I want to show you, this graph was a graph of numerical data. We can also graph categorical data. I'll try to squeeze this in here. So for example, let's say I wanted to look at habitat. So I'm going to make a graph, and I'm going to graph habitat. So I'm going to just drag that down to the x-axis. And now I can see an example here showing the habitats. And again, we can turn those dots into bars, and we can kind of see some information there. So again, it will give us the total for each different type of habitat. So you can see a lot more chose land than water, and there's a couple, or maybe just one, that lives in both spots, and that would be the gray seal. All right, what else can we do here? I think that's probably it. Oh, sorry, we can show the count. We talked about that before, but this will actually show the count in each bar. So here we can see that the first group has 1 item in it, the second group has 24, and the last group has 2. We can also show that as a percentage if we were interested in that. All right, that takes care of that. Now, the last little bit that we're going to do, we're going to look at some 2 variable data. So I'm going to create a graph again, see if we can fit it on this page. Here's my graph. I'm going to make it a little bit bigger. And this time, what I'm going to do is I'm going to do, as I said, 2 variable analysis. So I am going to graph, let's say, the mass. I'm going to grab the mass and stick it on the x-axis. And then I will grab the, let's say, I don't know if there's a relationship here or not, but the amount of sleep. So let's say I grab sleep and stick it on the y-axis. So then it gives me a scatter plot of all of the data here. Now this data isn't particularly, there's not a very strong relationship here at all, but I'm going to walk you through the process in case you found a relationship, just so you can see how that's done. So if you wanted to find the line of best fit, we can move over to the ruler here and choose a movable line. So we now have a line here, and we want to move that line to get what we might think is a line of best fit. So something maybe like this, maybe. Again, this data is not particularly useful for this, but I wanted to stick with one data set. So, all right, so we've put our movable line in. We might think that's where the line of best fit is. Now we can actually click on the ruler, and we can actually get it to show us the squares of the residuals. So the idea when you make a line of best fit is that you're trying to minimize the sort of sum of all of these squares. And you can see there's a number here. There's this number 1.984. We're trying to make that as small as possible. So I'm just going to play around with this line and see if I can make that number possible. And you can see that it looks to me like the smallest number I could get is somewhere right around here, 1.895, I believe. Now that was moving the line left and right, or kind of tilting it. Let's see if I move it down a little bit. Oh, look at this. I'm down into the 1.3s, 1.1s. Sorry, that was 1,000. I thought that was a decimal point. That's actually 1,000. So it looks like I can continue to make it smaller. And notice it gets bigger again. So my line of best fit is somewhere in here, wherever that smallest number is. And that looks like it's right about there at 740. And again, I can kind of tilt it up again. Oh, look at this. It's getting smaller. So it's just kind of a matter of playing around with it. I think I'm going to call it maybe somewhere right about there. All right, so I'm going to hide those squares because it's a little bit much to see. So it looks like that's the line of best fit. The nice thing here is that CODAP will actually give us the actual line of best fit. So to find the actual line of best fit, we can actually click on this least squares line. So it's giving us, I'll hide the movable line. You can see we were off by a little bit with our movable line, not sort of having played with it enough. But you can see, I think I'll just hide the movable line just to show you what happens here. So the least squares line is the line of best fit. It gives us the equation here. So it tells us the sleep is equal to negative 0.0017 times the mass plus 11.9. Now it gives us an R squared value. R squared value tells us is an indication of how strong this relationship is. And if it's one, or if it's one, it's a perfect relationship, meaning all of the dots lie perfectly on the straight line. And if it's zero, it means that there's no relationship at all. So you can see that this doesn't have a very strong relationship. So this number is actually very close to zero compared to one. And we talked earlier about finding the correlation coefficient, the R value. So in order to find the correlation coefficient, all we have to do is take the square root of this 0.228, and that would give us the correlation coefficient. So you can just go to your calculator and take the square root of 0.228, and that would give us an R value of 0.48. So I'm going to, probably worth jotting that down somewhere. So maybe grab a text box and say that the correlation coefficient is equal to 0.47. What I said. Oh, we'll do it to 2 decimal places. All right, so there's our correlation coefficient. We should probably label that so we know what it is and do a better job of keeping that organized. But just in the interest of time, we'll kind of move along from here. So obviously not a very strong relationship, but we can get that information very quickly. All right, so that's basically a quick summary of how to do. Oh, one thing that I didn't talk about that might be worthwhile, let me just get rid of that line of best fit, is maybe we would look at this data and say, well, what's going on with these points like way out here? I wonder if there's something interesting here. And that's one of the interesting things about looking at a data set, is to see what's happening. So we talked earlier about habitat, and some of these are land animals, some of them are water animals. Is it possible that the land animals sleep more than the water animals? Or is it possible that the meat eaters sleep more than the plant eaters, or so on? But what we can do is we can actually grab, let's say, the habitat. I'm going to grab habitat attribute, and I'm going to stick it on the y-axis, but on the right of the graph. And then the graph gets broken down into multiple sections. So you can see that the land animals here are in the middle, the water animals are above, and both are at the bottom here. So actually, we don't get a whole lot of information here on this, just because there's only one water animal and one sort of animal that fits into both categories. But sometimes that may be useful. And then if you wanted to, there is a way, I think, if you just move your mouse over to here and click, I think you can choose to remove this if you found that it wasn't very useful. All right, so that's basically an introduction to CODAP. What this allows us to do is it allows us to get the statistical values very quickly so that we can then do some analysis and make some interesting observations and provide some discussion around why certain things might be, or maybe make some predictions, some interpolation or some extrapolation based on the trends in the line of best fit and so on. So I wanted to show you the tool because it's kind of a nice sort of one-stop shop for all of your sort of data management needs. Now, what we haven't talked about, I guess what we should do, is to save this. So this is working on the web. It's not currently saved. If we want to save this, go over to this file menu over here and choose save. Now you might be wondering, how does it save if it's on the web? Well, what it does is it actually saves to your Google Drive. So you can give it a name. I'm going to call this mammals and click on save. So it says up here, all changes have been saved to my drive. And I'm going to start a brand new one just to show you how to get into the one that we've already created, just to make sure it's there. So I'm going to choose, now I'm going to go to the File menu and choose Open. And I'm not going to open one of these. I'm going to open something from my Google Drive. And I may not be able to find it. Oh, there it is, mammals. And you can see that all of our work appears here. I wonder if there's anything else that I wanted to show you here. I think that's probably it. One of the things that I should mention, though, is that if you go into Drive, if you didn't come to CODAP, you saved your work and you wanted to go into Drive, you can actually just click on the file once you have it. So I'm just going to bring my drive over here. I've got this file called mammals somewhere on here. Oh, this might take a little while. Normally I would organize things a little bit better, but I thought it would just be quick. So mammals. There's the mammals file right there that we just created. If I click on it, if I double click on it, I get the option here to open with, obviously this doesn't look very useful to me, but if I choose open with CODAP, it's automatically going to log me into CODAP with the file there ready to use. And there it is. All right, so that's a not so short introduction to CODAP. Hopefully you've learned a few things, and hopefully it will be useful to you.